All right, so we're going to talk about a math trick we could have done with the last example. So if you're wondering where this setup came from, just go back to the last video. It fell out of our rice table. So, this was, our KEQ equals our X values equilibrium concentration. So that's what we had. So this was our acetic acid equilibrium system. All right, and so we could solve this to look like, well, not solve it, but rearrange it to look like a quadratic equation. Not look like, to actually be a quadratic equation. I'm killing it at the start of this video. And, use A, B, and C, plug them into a quadratic formula calculator, get a number. That will work every single time. But it can be a little bit of work to rearrange everything. And the more work you do, the more likely you are to make an error. And also, if you don't have a quadratic formula calculator handy, it's not that beneficial. Unless you, want to actually hand calculate the quadratic formula, which I expertly recited from memory in the last video. All right, so we have this situation, and what we're going to do, and this is tricky, so I'm going to work hard to explain this, because it's not a math thing, it's an approximation, it's an assumption, which this is how you make the money when you're a theoretician, is every computer in the world can outperform me at every type of math imaginable, but none of them can make an assumption or an approximation like me. I would approximate the most difficult problem, unsolvable even, just most difficult imaginable, into something that was so simple with a solution that was so wrong, because that's a Joachim approximation right there. That was my bread and butter. Eventually I got better at making approximations that didn't ruin everything, but that's what our brains can really do. That's where human brains really outperform computers this day is. I can look up anything on the internet, it's going to beat me at memorization. If you've used Wolfram Alpha, you'll see that it will stomp you at a calculation. It can do it in a fraction of a second. But sometimes we can use our intuition, which you have to develop. And you can make a problem much simpler, more solvable. So that's where we come in. We have to think. All right. And so we already remember, you can go back to the last video, we already actually know what X is going to equal. There's no surprises here. We're just taking a different approach. All right. And so what we're going to do, I'm going to look at just this piece right here to start out. We're going to talk about that. So I have a situation where X can't be very large because KEQ over here is very small. That shift, I started out with all reactants, and KEQ says there's only going to be a little bit of product, right? 1.76 times 10 negative 5, that's my KEQ. That's my ratio of products over reactants. So I start with all reactants, and it's going to slide just a little bit, make just a little bit of product. So X is going to be a very small change. How do you know that? Again, it's kind of intuition, and I'll talk about really what I recommend is if you see a situation like this and you see what looks like a small number over here, make this assumption, see what number you get, see if it makes sense. And I'll tell you how. So I'm not great at explaining how to do it up front, but I'm very good at explaining how to know if you can keep your answer from it. And I think that's important. So we're going to look at this. And so 1.00 minus X, well, X is very small for the reasons I just talked about. That's how we can determine that. So 1.00 minus X, well, that's basically just 1.00. Okay? Well, it's a small change. What's it gonna do, right? And so we can do the following. I can go, well, then it's 1.76 times 10 to the negative 5. And so this is where we're going to make our approximation. And I'll say, oh, that's equal to, but we're approximating X squared over 1.000. Or essentially just X squared. I'm saying that this change is so negligible, I'm going to ignore it. I'm going to make my life simpler. Okay? And then what do? Well, if I square root both sides, I get 0.00420. Is that right? Did I add a 0? Nope. Equals x. Because that's just the square root of that number. Okay. And I'm going to tell you right now, that's a good number to keep. Just going to say that up front. But how do I know? How do I know that this is a good number? So how do I know this approximation worked? I mean, come on, it can't be that easy. Well, it isn't the exact same answer we got before, but it's close. All right, that's the first thing. It's close. Now, there's a very long and hard path to finding out that this works. And what you can do is you can plug this value for x back in the denominator and solve again. Or, and so that's called an iterative process. You keep feeding in, this x always stays a variable, this x becomes the previous answer. And you can cycle through and you can get a better and better answer. Or, this number right here is less than 1% of what we were subtracting it from. So that's a small change. So x is less than 1% of 1.000. So it is small. It is small compared to 1.00. So it works. All right. So if it was a plus x, you could still do that, as long as the change is small compared to the number that is being added or subtracted from. You can do that in the numerator or the denominator. Doesn't matter which one too much. There's a smart work problem where you have to make an approximation like this. I'm just going to tell you right now. I don't remember what number it is, but people would ask about it in the SRC pretty much every year. If you get stuck on that, I'm more than happy to help out. So this is going to come up on one smart work problem for sure. And this is going to be a very important idea for 223. So that whole acid-base equilibrium I did with acetic acid and acetate, making H3O plus as well, that's a whole chapter of your life in the future. I just snuck you guys a little niblet of it. But for now, just know how to use the Rice tables. You're not going to have to know this math trick, I'll be honest, on the exam. You're just going to have to know how to use a quadratic calculator. That's what it comes down to. And I'm happy with that. Like I said, that's a good standard. If you know how to do the Rice table, you know how to set up KEQ, and then you know how to rearrange it in a format that you can plug into a quadratic calculator, you're good in my book. Works for me. But I would not want to abandon my duties and not explain this trick to you. Now, I'm sure you have questions, so rewind like crazy, watch it a couple times, and if it's still not making sense, we can talk about it. We can Zoom meet, visit an office hour, whatever, email back and forth, whatever's most convenient for you. Because this is an approximation that will make 223 much easier for you. So, it's been a fun quarter. This should be the last video, so I'm going to pitch one more thing to you, and that's my course evaluations. At the time of recording this, I haven't actually written them yet, but I have a pretty good idea of what I'm going to do. So I've tried out a number of different tools with this class. This is the first time I ever taught an all online chemistry course. And so please understand that the feedback I'm looking for is, in general for an online environment, because you guys are going to have a lot of sway with my future approach for the next pandemic or whatever. The the labs, we'll have tried out a number of things. We shipped you data, or well, I guess I shipped you data. I mean, John was doing the same thing. That's why I'm saying we in his section. Shipped you data, had you do an experiment at home, had you do a little short paper, and then some online simulation stuff. And I believe we'll have done 2 different formats of that, Smart Sparrow and then FET, to see how that goes. And so I'm going to ask some questions about that. So teaching lab online is kind of the forefront of chemical education. And so I basically just tried a little bit of everything, and I would love to hear your feedback on that. I'll try to ask questions that will guide that way. And then, you know, the online instruction, I guess actually I just changed it. So you didn't write a paper, you did forum posts. So I wanted you guys to kind of talk about stuff. So that's what it was for the lab. So if you're wondering when you wrote that paper, you didn't. And hopefully the forum posts are going well. I just opened them up before I filmed the day because it's week 5, just so you know. And then the videos, hopefully those are helpful. Zoom office hours. If there's anything that you wished I'd been doing all quarter, please tell me. And hopefully you've already told me because the quarter isn't over when I film this, but I am all ears for ideas because I've never taken an online course as a student. And like I said, this is the first time I've taught one. So I don't have a lot of experience to lean on. So I really am hoping you guys will share your experiences with me. So please take the time to write evaluations. Don't just grade things 1 to 5, but in the short answer stuff, please share your perspective and help me do this better in the future, because I will definitely have to this summer. It won't be Gen Chem, it'll be another chemistry course. And I may have to this fall as well. So I do value your feedback. And if it's like, I wish you'd just gotten a haircut and stopped growing that gross neck beard, okay, sure. I don't know if that'll help me. That's not going to stop me from doing it again this summer, but thank you for your input. But like I said, if you have any ideas, I am all about stealing other people's ideas if it makes the experience better for my students in the future. So, you know, when I teach a class live, I'm leaning on my experiences as a student and trying to adapt them to a world that's now shifted over a decade from then. And in the online environment, I have to solely rely on your feedback because I don't have my own experiences. So again, this will be the last time I'm begging you, please fill out those course evaluations. Give me a good score, give me a bad score, whatever, but give me tangible feedback on all the different things I tried. What worked for you, what didn't, what could I have done? Hopefully I'm trying to develop, I feel like everyone's a little disconnected right now, so I'm going to try to develop a weekly forum. That's kind of where I was going with the C&E news articles discussion, was to hopefully get you into a weekly forum, or at least chapter by chapter forum discussion that I'm going to start adding to Moodle every week. And hopefully that'll help build a sense of community, because I feel like for the first four weeks of the class here, since we're just starting week 5, we haven't really had that too much. I think there's been a couple of groups of people that maybe stayed in contact, but it'd be nice to get a little bit broader. It's a little too easy to get cut off and feel alone right now with everyone, you know, everything's shut down. And so hopefully, you know, you can kind of build that peer base in the class. And if I haven't, let me know what I could do to do that. And if I have, let me know how it worked for you. So, yeah, I promised you I wouldn't beg anymore, but please fill out those course evaluations. It's been a wild ride. This will be the last time I teach in this classroom, unless I have to pop in because I screwed up a video or something. So, it'll probably be the last time on campus, because I'm just going to do a DocuCam for my online course so I can stay mobile, because I'll probably be moving. And yeah, so have a good summer, and don't forget that document, by the way, to help you transition from 222 to 223. Just kind of bridges the gap. So a little bit of a reminder of what we did, and a little bit of a heads up of what you're going to do next, and kind of putting them all together. So yeah, thanks for hanging in there the whole time.